In this lesson, we will focus on the working principle of the three-jaw chuck in the design of centering and clamping lathe fixtures in Project 2. The three-jaw chuck is an extremely common and important fixture in lathe machining. It enables the centering and clamping of workpieces and is widely used in various mechanical processing scenarios. Next, we will delve into the structure and the working principle of the three-jaw chuck, as well as its application in actual machining. We will also appreciate the design ingenuity and craftsmanship embodied within it. In the field of machine tool processing, the design of centering and clamping lathe fixtures is a critical technology, with the three-jaw chuck being a quintessential example holding significant importance. Basic structure of the three-jaw chuck. The three-jaw chuck primarily consists of the housing, bevel gears, a flat thread, and jaws. The housing serves as the foundational support structure of the entire chuck, providing space for the installation and operation of other components. The bevel gears typically include one large bevel gear and three small bevel gears. The large bevel gear meshes with the flat thread, while the three small bevel gears are evenly distributed around the large bevel gear and engage with it. The flat thread is a crucial component for achieving the synchronized movement of the jaws in the three-jaw chuck, working in conjunction with the threads at the base of the jaws. There are generally three jaws, which are the parts that directly contact the workpiece and perform the clamping function. Working principle of the three-jaw chuck. The working principle of the three-jaw chuck is based on a combination of gear transmission and thread transmission. When we use a wrench to turn the small bevel gears, the small bevel gears drive the large bevel gear to rotate. Since the large bevel gear is integrated with the flat thread, the rotation of the large bevel gear causes the flat thread to rotate as well. The flat thread works in conjunction with the threads at the base of the jaws, and its rotation drives the three jaws to move radially simultaneously. When the flat thread rotates clockwise, the three jaws simultaneously move towards the center, thereby clamping the workpiece. When the flat thread rotates counterclockwise, the three jaws simultaneously move outward, releasing the clamping on the workpiece. This design allows the three-jaw chuck to automatically center itself, meaning that regardless of the variation in the workpiece's diameter, the three jaws can always move uniformly towards or away from the center of the workpiece, ensuring that the center of the workpiece coincides with the center of the chuck. Advantages and application scenarios of the three-jaw chuck. One of the greatest advantages of the three-jaw chuck is its automatic centering function. In actual machining, it can quickly and accurately clamp workpieces, significantly enhancing processing efficiency. For instance, in the mass production of shaft parts, using a three-jaw chuck allows for rapid workpiece clamping, reducing clamping time and increasing production efficiency. Moreover, the three-jaw chuck has a relatively simple structure, is easy to operate, and is cost-effective, which is why it is widely used in conventional lathe machining. It is suitable for processing various regular-shaped workpieces, such as circular and regular polygonal shapes, including turning and grinding operations of shaft and disc parts. Accuracy analysis of the three-jaw chuck in practical applications, the accuracy of the three-jaw chuck can be affected by various factors. For example, the wear of the jaws, the wear of the flat thread, and the installation accuracy of the chuck can all impact the centering accuracy and the clamping force of the chuck. To ensure machining accuracy, it is necessary to regularly maintain and service the three-jaw chuck, checking for wear on the jaws and flat thread, and promptly replacing severely worn components. Additionally, when installing the chuck, it is important to ensure the installation accuracy to avoid affecting machining accuracy due to improper installation. Integration of the three-jaw chuck with ideological and political elements. The design wisdom of the three-jaw chuck's uniform clamping is akin to the embodiment of the 3 oaths and 4 strix spirit of the great craftsman Wang Jinxi in mechanical structures. The 3 oaths and the 4 strix refers to being honest, speaking honestly, and doing honest work in revolutionary endeavors, and in work having strict requirements, meticulous organization, a serious attitude, and strict discipline. The 3 jaws of the chuck are evenly distributed, applying the same clamping force to the workpiece, much like the emphasis on rigor, fairness, and truthfulness in the 3 oaths and the 4 strix spirit. In mechanical processing, we should learn from this spirit, approaching the machining of every part with rigor and seriousness, ensuring that every dimension and every precision meets the requirements, just as the 3-jaw chuck can precisely clamp each workpiece. Operating precautions for the 3-jaw chuck. When using a 3-jaw chuck, there are several operational precautions to keep in mind. Firstly, before clamping the workpiece, ensure that both the jaws and the surface of the workpiece are clean to prevent any debris from affecting the clamping effectiveness. Secondly, when clamping the workpiece, select the appropriate clamping force based on the material, shape, and size of the workpiece. This is to avoid damaging the workpiece or jaws due to excessive clamping force, or causing the workpiece to become loose during machining due to insufficient clamping force. Additionally, during operation, pay attention to safety to avoid fingers being caught by the jaws. Maintenance and the care of the 3-jaw chuck. To extend the service life of the 3-jaw chuck and ensure its working accuracy, regular maintenance and care are necessary. Regularly clean the oil and debris inside the chuck. Check for wear on the jaws and the flat thread, and promptly add lubricant as needed. Additionally, avoid collisions and damage to the chuck, and store it properly when not in use. In this lesson, we conducted an in-depth study of the working principle of the 3-jaw chuck within the design of centering and clamping lathe fixtures in Project 2. We learned about the basic structure of the 3-jaw chuck, including components such as the housing, bevel gears, flat thread, and jaws. We mastered its working principle, which involves achieving the synchronized radial movement of the 3 jaws through gear and thread transmission, thereby enabling automatic centering and clamping of the workpiece. We recognize the advantages and application scenarios of the 3-jaw chuck in actual machining, as well as the factors affecting its accuracy and the corresponding solutions. At the same time, we appreciated the alignment between the design wisdom of the 3-jaw chuck's uniform clamping and the 3 odes and 4 striks spirit of the great craftsman Wang Jingxi. Finally, we learned about the development trends, operating precautions, and maintenance methods of the 3-jaw chuck. I hope that through this lesson, everyone has gained a more comprehensive and in-depth understanding of the 3-jaw chuck, enabling you to better apply it in your future studies and work.